Hi everyone. In this video, we're going to be doing A Level Maths 9709, paper 31, October, November 2025, Pure Maths 3. This paper is 1 hour 50 minutes long, so we'll try to finish within that time limit. So let's get started. Okay, so for the first question, we need to find the exact value, so no decimal approximations of this definite integral ln 3x. So we need to give our answer in this form where a and b are integers. Okay, so to integrate ln functions, since we don't know like a direct formula to integrate them, we can think of ln 3x as ln 3x times 1. Okay, and now instead of just integrating ln 3x, we're going to integrate ln 3x times 1. So what this means is we'll basically be using our integration by parts, since that's what you use when you want to integrate a function that is expressed in terms of a product of two other functions. So that's what we're gonna do. So let's choose our u and our dv dx. So this is going to be our u, since so to choose our u, we need to use this rule, liate. So L-I-A-T-E. So L is logarithm, I is inverse functions, A is algebraic, so your x squared, x cubed, x whatever to the power of n, and trigo, and lastly exponential. So to use this in order to figure out our u, we are gonna state what type of functions we have in this liate. So we have a ln expression, which is a log, as well as one, which we can count as algebraic. And whichever one appears earlier in the list, so like in this case, log appears first before algebraic, we're gonna let the one that appears first be our u. So that's why ln 3x is going to be our u. And hence, 1 is going to be our dv dx. So let's find our u dx and v. So du dx just going to be 1 f prime x over fx. So you just take your 3x in the denominator and differentiate your 3x, you'll get 3 for your numerator. And then you simplify, you would just get 1 over x. And then you take your dv dx, you integrate it, you'll get v equals to x. So now, to integrate our ln 3x times 1 dx with respect to 2 and 1, the limits, we are going to first multiply u and v together. So that's just x ln 3x. And we're not going to forget our limits. We're going to put the limits outside of the uv expression. So 2 and 1 will be here. We'll substitute them later. And then you minus the integral of v times du dx. So in this case, it's x times 1 over x, which is just 1 dx. Again, don't forget your limits. Yeah. So this is our final expression, and we're going to evaluate it. So first, let's evaluate the x ln 3x and the upper limit 2 and 1. So let's substitute 2 first. So you get 2 times ln 3 times 2, which is 6. And then you subtract the same expressions when x equals to 1. So you substitute 1, so you get 1 times ln 3 times 1. So you just get ln 3. And minus, now let's evaluate this integral. So 1 dx, that's just x in this case. And don't forget your limits, 2 and 1. And in the meantime, let's also simplify this. So using a product rule, we can bring this up to be the power of b. So instead of a ln b, this becomes ln times b to the power of a. So similarly, this becomes ln 6 squared. So 6 squared, that's just 36 minus ln 3. Now let's evaluate this. So this is just 2. Don't forget your brackets, 2 minus 1. Now we're going to simplify this using our addition law. So we're going to use the ln a minus ln b equals to ln b over a. So similarly, this would just be ln 36 over 3. So 36 divided by 3, that's 12. And minus bracket 2 minus 1, that just gives you minus 1. Okay, let's see. Okay, it's not in the form that they want us to give. So we're going to swap the two terms to give us minus 1 plus ln 12. Yeah, so this would be a final answer for this first question. If you want to be very sure that you have the correct answer, you can type ln 12 minus 1 into the calculator and write down whatever your calculator shows somewhere in here. And then you can type the definite integral into a calculator and see if it gives the same answer as ln 12 minus 1. Yeah, so that is if your calculator supports that. Yeah, so with that, let's head on to the next question. Okay, so for this second question, for the first part, we need to show that this logarithmic equation can be written as a quadratic equation in x. So it has to be in the form ax squared plus bx plus c equals to 0. Okay, so in order to do this question, we're going to first simplify whatever we can find. So let's just copy it down first, and then we'll get to simplifying. Okay, so first things first, what I realize is we have this like coefficient here, and this coefficient would have helped if our answer here, like the number outside of our base, was the same, but in this case, they're not the same. So what we can do with this coefficient is we can bring it up to be the power of whatever this number is. So we will get log base 4 2x plus 1 equals to log base 4 3x minus 1 squared minus 2. Okay. And now our next step would be to bring all the logarithms to one side and keep everything else on the other side. So we can bring 2 over to the left-hand side. So we can add 2 to both sides to bring it to the left-hand side, and we can subtract this from both sides to bring this log to the other side. So we'll get 2 equals to log base 4 3x minus 1 squared minus log base 4 2x plus 1. Okay, so now we realize that we basically have 2 logarithms with the same base but different like b's, like different numbers. I don't know the term, but yeah, these two are different. So if we have this case, yeah, we can express it like this. So it's in the form log b minus log a. This would just be log b over a. So we also use this in the previous question. So hence we'll get log base 4 over 3x minus 1 squared over 2x plus 1. Sorry, it's not really clear in here. I'm going to just rewrite it so that it's clearer. So yeah, this is a square and this would be equal to 2. Okay, so now when we have log on one side and a constant on the other, we can rearrange this so that we can get rid of the log. So this comes down to the very fundamental law that we learned. So ax, let's say a to the power of x is b, and um, we can re-express x as log base a, and then the main number would be b. So yeah, we're gonna use this idea. So let's take our base, which is 4, and then this would be our power to the power of 2 equals to, yeah, this answer, 3x minus 1 squared. So I believe this is a good time to expand it. So I'm going to expand it now. So 3x squared, that's 9x squared minus 2ab. So a is 3x, and then b is 1 plus 1 squared over 2x plus 1. Okay, so now we can simplify both sides. So we got 9x squared minus 6x plus 1 over 2x plus 1 equals to 16. And now let's multiply both sides and simplify until we get a complete quadratic equation. 16 times 2x plus 1. Sixteen times 2, that's 32x plus 16. And we can move everything to the left-hand side. So 9x squared minus 6 minus 32, that is minus 38x. 1 minus 16, that is minus 15, equals to 0. So yeah, we can write shown in here, even though they didn't tell us what quadratic equation we have to show. Yeah, so this would be our final answer for the first part. Let's head on to the next part. Okay, so now they told us hence. So we obviously have to use the answer from the previous part. We need to solve this equation that we're given in our previous part to simplify. Let's see. Yep, it's the exact same. So yeah, we can just copy down a quadratic equation and then just solve it. So you can use factorization or quadratic formula, whichever is possible. So I'm going to see if you can factorize it. So, okay, you cannot. So no choice but to use the quadratic equation. So our A is this, B is minus 38, and C is minus 15. So X would be equal to minus B, so minus negative 38. So that's just 38 plus minus square root of B squared, which is minus 38 squared, minus 4 times A, which is 9, times C, which is negative 15, over 2 times A, so 2 times 9. Okay, so I'm just gonna get the exact answer first. Yeah, that's how I like to do it. Just keep everything in exact form until we get our final answer. So 9 minus 38 minus 15, you'll get 19 over 9 plus 4 over 9 square root 31. And obviously the other answer would just be the same, except the plus is replaced with a minus. So 19 over 9 minus 4 over 9 times square root 31. And we're going to see which one is positive. So this is the positive one. And that is negative. So why this matters is because in a logarithm, this number in here, this number, like after the base, it cannot be less than 0 because, as I said, this is what a logarithm represents. And as you know, for any like exponential, so 3 to the power of 2, 3 to the power of half, 3 to the power of -1, it is always more than 0. So we have to check whether by substituting either of these, whether both of these will be more than 0. So I'm just going to quickly check that. So let's do for 2x plus 1 for this one first. Yeah, actually, I don't think we have to do for this because for sure both of them would be net. For yeah, both this one be positive. So let's do this one, 3x minus 1. So 3 times 19 over 9 plus 4 over 9 squared 31 minus 1. Yeah, so yeah, this is positive for both. Yeah, let's see for the second one, the negative one. So I'm going to do 3x minus 1 first. Okay, unfortunately, for this one, 3x minus 1 becomes negative. So immediately we need to reject this answer. And hence, we can say that this would be our final answer. So for final answers, you need to give to 3SF if the question did not specify. So final answer is 4.59 to 3SF. Yeah, so this would be final answer for this part as well as the entire question. Let's head on to the following question. All right, so for this question, we are told to express this trig equation in this form. So our formula, yeah, where r is more than 0 and alpha is between 0 and 90 degrees. Yeah, so this is a classic R formula question. So you would have to express like a given trig equation in this form. Yeah, so let's do that. So unfortunately for our case, the equation that we are given, it's like not fully expanded. So it's supposed to be like A sine X plus B cos X or something like that. So we have to make sure it's in that form first. So let's copy it down. So for this part, we can use our addition formula, which is given in our MF19. Okay, so we have it right here for sine A plus cos B. You would get sine A cos B plus cos A sine B. So this would basically, this would basically just be sine X cosine 45 plus cos sine cos A, so cos X sine 45. Okay, let me double check. Yes, sine A cos B, cos A sine B. Yeah. Okay, so yeah, we got the correct expression plus cosine X. Okay, now we can expand out everything and evaluate our cosine and sine 45. So we're going to do that at the same time. So cosine 45 degrees, that is square root 2 over 2. So 3 square root 2 times square root 2 over 2 sine X plus sine 45. I believe it should be the same value. Yeah, square root 2 over 2 as well. Cos X plus cos X. So expanding everything, you would get 3 sine x plus 3 cos x plus cos x. And simplified expression would be 3 sine x plus 4 cosine x. So now we can finally express it in our R formula. So to do that, what I always like to do is to also fully expand out the R formula so we can know what our alpha is. But if you can memorize the format, then good for you. So R cos x minus alpha, we can expand it out using our cosine formula. So cosine A minus B, you get cosine A cos A cos B plus, because the plus is below and minus is below on the other side. So cos A cos B plus sine A sine B. All right, so this is just going to be cosine x cosine alpha, opposite signs of plus, sine x sine alpha. And expanding, you would just get R. I'm going to keep the cosine x on the very end. So R cosine alpha cosine x plus R sine alpha sine x. And we can equate it to our expression here. So we can write it as 4 cosine x. Like I'm trying to equate the coefficients, so I'm swapping the terms so that it it matches exactly. So 4 cosine x plus 3 sine x. Yeah, so you can see it matches. So we can clearly see that R sine alpha is 3 and R cosine alpha is 4. So R sine alpha is 3, R cosine alpha is 4. So what we can do, we can divide these two. So R sine alpha over R cosine alpha, you get tangent alpha. So tangent alpha is 3 over 4. And you can get your alpha as just tangent inverse 3 over 4. And when you're getting your alpha, make sure it's in degrees since the domain is given in degrees. So if you have to change, please change. You would get 36.9 degrees to 1 decimal place, since this is our final answer. And then to get our R, we can just square our coefficients. So 3 square plus 4 square, we square coefficients, then we add them up, and then we take the square root. So in this case, R is just 5. And therefore, our final answer is R5 cosine bracket x minus alpha. So x minus 36.9 degrees. So yeah, this would be our final answer for the first part of this question. Let's head on to the next part. Okay, so for the second part, they told us hence. So we have to use our answer from the previous part again. We need to solve this trig equation for this domain of theta between 0 degrees and 180 degrees. Okay, so since they told us to use hence, we have to see how similar this equation is to the equation we simplified at the top. So let's see the coefficients. So 3 square root, it has the same sign, also the same. X plus 45. Here we have 3 theta plus 45 plus cosine 3 theta. And then after that, there's cosine x. Yeah, so everything on the left-hand side of the equation is the same, except that instead of x, we have 3 theta. So yeah, let's use this result that we got here and replace the x with 3 theta. So 5 cosine bracket 3 theta minus 36.9 degrees equals to -4. So let's isolate the cosine term. So divide both sides by 5, you'll get cosine 3 theta minus 36.9 degrees equals to -4 over 5. Okay, so now that we've isolated it, now we are going to, what do we call that? Modify the domain that we're given. So instead of theta, we're now going to make the domain in terms of 3 theta minus 36.9. So yeah, 3 theta minus 36.9. So for 180, we can multiply it by 3 first. So you get 540, and then you subtract it with 36.9. Okay. So for lower limit, for our upper limit, sorry, we get 503.1 degrees. As for the lower limit, we get 3 times theta, so 3 times 0 minus 36.9. We get exactly negative 36.9 degrees. So this would be our domain that we're going to be working with to find our expression inside the cosine function. Okay, so let's draw our unit circle and see which quadrants our domain for this covers. So we start with negative 36.9. So that's a negative acute angle. So this starts obviously below the horizontal line. So 0 is here, and then you go clockwise for negative angles. So this is where we start, and then we go to about 500. So this is 0. Okay, and then one round is 360, and 360 plus 90, you get 550. So yeah, this is probably where it stops. Yeah, but let me check. 503 minus 360. Oh, never mind. Sorry. It actually goes 143 degrees later. So yeah, this is, sorry, so this is 360, and then plus 90, that is 450, and then 450 plus 503 minus 450. Okay, 53 degrees more. So yeah, so this is where it ends. So I'm just gonna draw like this. So this is this is 0, and then you go one whole round. And this is 360, and then beyond 360 we go like an obtuse angle for our final value. So this is our domain for 3 theta minus 36.9 degrees. So as you can see, it covers all 4 quadrants. Yeah, so A, S, T, C, let's label them and state which ones are negative for cosine and positive for cosine. So this is obviously positive for all. This negative for cosine. This is negative for cosine, and this is positive for cosine. So since our cosine is negative, we're going to ignore these 2 quadrants, A and C, and we're just going to focus on the second and third quadrant. So to get our angle in the second quadrant, first angle in the second quadrant, it is just an obtuse angle from 0 degrees anti-clockwise all the way to this. So yeah, it's just a normal obtuse angle. And to get that, we have to get our basic angle, which is from here. We have to do 180 minus the basic angle. And to get the basic angle, just take the cosine inverse of 4 over 5, like without the negative sign. Okay, so let's do that. Sorry, 3 theta minus 36.9, 180 minus the basic angle. So that's just cosine inverse 4/5 without the negative angle of the negative sign. So 3 theta, you get 180 plus 36.9 degrees minus cosine inverse 4/5. And then you divide by 3 on both sides, you get 1/3 times 180 degrees plus 36.9 minus cosine inverse 4/5. So yeah, just type it into your calculator. 1/3 times 180 plus 36.9 minus cosine inverse 4/5. Okay, so we got 60.0 degrees to 1 decimal place. Yeah, so that's our first answer. Now we are going to find our second answer in the third quadrant. So for third quadrant, it's going to be a reflex angle between 180 degrees and 270 degrees. So to get that, you just add 180 plus the basic angle, which is from here to where the angle ends. Yeah, so again, the basic angle is just cosine inverse 4/5. So let's do that. So 3 theta minus 36.9, you get 180 plus cosine inverse 4/5. Yeah, I'm just going to isolate theta immediately. So it's just 1/3 times 180 plus 36.9 degrees plus cosine inverse 4/5. You would get 84.6 degrees to 1 decimal place. Yeah. So that's our second answer. Let's see if we have a third answer for our final answer. So it has to be within this range. So to get our final answer, instead of 180, this is going to be 540 minus cosine inverse 4/5. So 540 minus cosine inverse 4/5. I'm just going to write here in short form. Let's see if it's within the range. Okay. I don't know if we should take it. Okay, it's actually exactly like 503.13, which is exactly the upper bound of our domain for 3 theta minus 36.9. So yeah, I don't think we're supposed to take it because it's out of range. So yeah, this would be our final two answers, 60 degrees and 84.4 degrees. And if you want to make sure you got the right answers, substitute the exact values. So these values back into this equation. And if you get -4, you are good to go. So yeah, this would be our final answer for this part as well as the entire question. Let's head on to the next question. Okay, so for this question, we're given a diagram that shows the graph of y equals to e to the power sine 2x times cosine 4x for this domain of x between 0 and pi/4 inclusive and the maximum point m. So it's here, and we need to find the x coordinate of m. Okay, so since m is a maximum point, immediately you should know that at m, dy dx must be equal to 0 whenever you substitute the x coordinate of m into dy dx. So let's find dy dx first. So dy dx, just be dx of e to the power of sine 2x times cosine 4x. Okay, so the way we differentiate this, since it's a product of two functions, e to the power of sine 2x times cosine 4x, we obviously have to use our product rule. So how I like to do it is I would keep the first function and differentiate the first function. So keep the first function, so e to the power sine 2x, and differentiate the second function, cosine 4x. So to differentiate this, we know the derivative of cosine is negative sine, and we also have to use a chain rule where we have to differentiate we have to multiply by the derivative of the inner term. So in this case 4x, the derivative is 4. So this would be 4 times negative sine 4x. So minus 4 sine 4x. And then we add it with the derivative of and then we add it by keeping cosine 4x and differentiating e to the power of sine 2x. So now it's like the opposite, okay? So let's differentiate e to the power of sine 2x. So the derivative, to get it, you first differentiate the power. So differentiating sine 2x, you would get cosine 2x. You differentiate the outer function, so cosine 2x. And don't forget the inner function. According to a chain rule, we need to multiply by the derivative of the inner function, which is just 2. And then you multiply by the original exponential function, so 2 cos 2x times e to the power of sine 2x. And then you can keep your cosine 4x. So let's tidy up this expression a little bit. So 2 cos 2x cos 4x times e to the power of sine 2x minus 4, minus 4 sine 4x times e to the power of sine 2x. Okay, so now we can, all right. So what we can do now is to re-express cosine 4x and sine 4x in terms of cosine slash sine 2x. So to do that, you just have to know that 4x is twice of 2x. And so when you do that, so cos 2x times cosine 2 times 2x, you can use the double angle formula. So I'm gonna show it. So sine 2 times 2x e to the power of sine 2x. So for cosine, the double angle formula is cosine 2a. We have these three formulas. So let's see which one would be the most suitable. Let's see. Okay, let's just choose cos square a minus sine square a. So this is going to be 2 cosine 2x times cos square 2x minus sine square 2x times e sine 2x. And then for sine 2a, we just have 2 sine a cosine a. So 4 times 2 sine 2x cosine 2x. Okay, and then for the e to the power sine 2x, since it's a common factor in both of them, let's just factor them out at this point. So this would be e to the power of sine 2x. Okay, so let's see if we can simplify these two expressions. Yeah, I believe it should be possible. So we can see that there's also another common factor in both of them, which is cosine 2x. So we can factor that out as well. So we get cosine 2x times e to the power of sine 2x. So bracket 2 times bracket cosine square x minus sine square x. So 2 cos square 2x minus 2 times sine square 2x. And then minus 4 times 2, that's minus 8 sine 2x. Okay, so now since everything in this bracket is in terms of cosine, we can re-express the sine in terms of cosine as well. So cosine 2x times e to the power of sine 2x. Get cosine. I'm sorry, the cosine square, we're gonna re-express it in terms of sine. So this is just gonna be 1 minus sine square 2x minus 2 sine square 2x minus 8 sine 2x. This will be equal to cos 2x times e to the power of sine 2x. 2 times 1, that's 2 minus 2 sine square 2x minus 2 sine square 2x minus 8 sine square 2x. Okay. Oh, we're given 2 pages. Okay. So cosine 2x times e to the power of sine 2x. Okay, so since all the coefficients are even, we're going to factor out 2 from all of them. So 2 cos 2x times e to the power of sine x. So this would be minus 1 minus, oh, sorry, this is 2x minus 4. So that's minus 2 sine square 2x. And minus 8, since we factored out 2, that just becomes minus 4 sine 2x plus 2 divided by 2, that's just 1. Okay, so let's equate this to 2. Okay, let's factor out the negative 1 as well from the quadratic expression. So I get negative 2 cos 2x times e to the power of sine 2x times sine squared 2x plus 4. Oh, sorry, this is supposed to be 2 plus 4 sine 2x minus 1 equals to 0. So yeah, let's equate both factors to 0. So minus 2 cos 2x times e to the power of sine 2x equals to 0. So we can divide off minus 2 and e to the power of sine 2x, since we know this cannot be equals to 0. E to the power of any number cannot be 0. And this is obviously not 0, so we're just left with cosine 2x equals to 0. So let's take a look at our domain for x. So since we're dealing with 2x, we're going to double it. So instead of just from 0 to pi over 4, this is going to be from 0 to pi over 2. And we know that cosine 2x, cosine whatever equals to 0, our first answer is always pi over 2. And since that's the only one in the region, that will be our final answer, then x would be pi over 4. But if you look at our diagram, obviously m is not that. So we are just going to reject it. Okay. All right. Now we can do the second one. So sine squared 2x plus 4 sine 2x minus 1 equals to 0. So you can see that this is a hidden quadratic in terms of sine 2x. So how we deal with this? Yeah, we're just going to deal it like any other quadratic equation. We see if we can factorize first, or you can just straight away use your quadratic formula. Okay, unfortunately, you cannot factorize. So yeah, onto the quadratic formula. So sine 2x minus b, so minus 4 plus minus b squared, so 4 squared minus 4 times a, which is 2, times c, negative 1, over 2 times 2, which is 8. Yeah, so yeah, let's just continue to the next page. So we'll write both of our answers for sine 2x in here. So just put into a calculator. 2, 4, minus 1. First answer you get minus 2 plus square root 6 over 2. So this is positive. And then the second answer would just be the conjugate, which is minus 2 minus square root 6 over 2. And this is negative. Okay, so let's take a look at our domain. So this domain from 0 to pi over 2 is the same as from 0 degrees to 90 degrees. And if we draw our unit circle, 0 to 90 degrees just covers the first quadrant where all the trig ratios are positive. So we're going to have to reject this. Yeah. So we're only left with this, and we can find our angle 2x, which is just sine inverse square root 6 minus 2 over 2. And then you can find your x by dividing dividing by 2 on both sides, and you get half sine inverse square root 6 minus 2 over 2. And yeah, make sure your final answer for x is in terms of radians. So change the degree, change the mode of your calculator to radian mode, and get half sine inverse square root 6 minus 2 over 2. And you'll get 0.113 to 3SF as your final answer. So yeah, this would be our final answer for this entire question. Let's head on to the next question. Okay, so for this question, we're told that the shaded region on the diagram shows points representing complex numbers Z, defined by two inequalities. The shaded region is bounded by a circle and a line parallel to the imaginary axis. So it's all shown in the diagram. So we have circle, and this is the line that they're talking about. And the boundaries of the region are included in the shaded region. So this last point is very important when we need to like find out the inequality. So for the inequality sign, it definitely cannot be just more less than or more than. It has to be less than or equal to, more than or equals to. So I need to basically include the equals to sign. Yeah. Okay, so we need to find the two inequalities in terms of Z that define the region. Okay, so the first part is obviously like a backwards. You have to think backwards for this question. Like instead of you sketching the Argand diagram, where instead of them giving you the inequalities and you're sketching the Argand diagram, now it's the other way around. They give you the sketch and you have to figure out what the inequalities are. Okay, so we can see that only a portion inside the circle and the boundary inside the circle is shaded. So yeah, we can say that without like this boundary, this line, the whole circle would be shaded. So the first one is going to be in the form of z minus a plus bi, modulus of z minus a plus bi, less than or equal to the radius of the circle. So A and B, A is the x coordinate of the center, and B is the y coordinate of the center. So let's write that down. So this is modulus of z minus A. So A is 1 and B is minus 2. I, modulus of less than or equal to, what's the radius? So start from 1 to the n, which is 3. So the radius is just 2. And you would get z minus 1 plus 2i less than 2. So this is the first one. Now, obviously, there's a second one, because if it's just this first inequality, the whole inside of the circle would be shaded. So the other inequality would be related to this line, this vertical line. So this vertical line, as you can see, is only affecting this axis, right? So you can see that everything to the right of 2 is included. So hence the other inequality would be real z, the real part of z is more than or equal to 2. Yeah, so that would be our second inequality. And yeah, these two would be our final answers for the first part. Let's head on to the second part. Okay, so for the second part, we're told to calculate the least value of argand z for the points in this region. So yeah, first we need to know that argand z is just the angle from a point in the region to the real axis. So in this example, okay, so that's, yeah, okay, let's take this point. So the argand z of this point, it would just be the angle from the real axis to the line connecting the origin to the complex number. So yeah, we need to find the least angle that the points in the shaded region can possibly be. So if you take out a ruler and you pivot it at the origin and then you just rotate it around like the shaded region, you would find out that the least value of argand z, or the least possible angle for points in this shaded region, including the boundary, is this exact point here, as you can see. Yeah, I don't think you need a ruler to see, but if you want to double check, you can use the ruler. Yeah, so even without the ruler, you can see that this has the smallest angle relative to the real axis as the 0-degree line. So yeah, we're going to find out what this angle is, this argand z. So yeah, to do this, we need to know our trig. So yeah, we are going to form the right angle triangle. So this side here would just be the y value. So it's just equal to the imaginary part of this complex number, and this one is the real part, which is just equals to 2. Okay, so yeah, to find this point of intersection, what we can do is we can form the Cartesian equation of the circle, as well as the line parallel to the imaginary axis. So the circle equation will be x minus the x coordinate of the center, so x minus 1 squared plus y minus the imaginary the y minus the y coordinate of the center, so it's just -2, so y minus -2, that's just y plus 2 squared equals to r squared. So r squared is just 2 squared. Yeah, so it's just 4. So yeah, so this equation 1, and then the line, that's very simple, just x equals to 2. So just sub 2 into 1, and we will take the bigger value of y as our answer. So 2 minus 1 squared, you just get 1 plus y plus 2 squared, you get 4. And then y plus 2 squared, sorry, you would get 2 minus 1 squared, yeah, y plus 2, yeah, you get 3. And y plus 2, you get square root of plus or minus 3. So square root 3 or minus square root 3. Then you would get y equals to square root 3 minus 2, or y equals to negative square root 3 minus 2. So let's see which one is bigger. So this is negative 0.26, and this is -3. So yeah, we're going to reject this. Yeah, so this would be our y value. So yeah, this would be also, and hence this would be the height. Okay, like the modulus of this would be the height, of course. So we're gonna factor a -1, then we get 2 minus square root 3. So to get the angle, we can see this angle is opposite of this and adjacent to this. So we're going to use the tangent ratio. So argin z is just tangent inverse y, negative y. So negative of square root 3 minus 2 over the adjacent side, which is just 2. Okay, so yeah, doing this, you would get 2 minus square root 3 over 2. Your answer must be in radians for this. You would get 0.133 to 3SF. Yeah, this would be our final answer for this part, as well as the entire question. Turn on to the next question. Yeah, sorry, everyone. So apparently I misunderstood this question. So least value means like the magnitude of the angle. So it's not like the angle of the least size. So since this is a negative direction, this would be the angle of the least value of arguments at this angle. So yeah, it's not a big deal. So the y coordinate for this is negative square root 3 minus 2, negative square root 3 minus 2. Yeah, so this is going to be a tangent inverse negative square root 3. So okay, we have to also factor -1, so it's just -1 times square root 3 plus 2 over 2. Yeah, and you're supposed to get minus in radians. You can also do in degrees, minus 1.0823 SF. So yeah, this would be our final answer for this second part, as well as the entire question. Let's head on to the next question. Okay, so we're told to solve this quadratic equation. So almost all the coefficients are complex numbers. And we need to give our answers in the form x plus iy, where x and y are real. Okay, so this is just a normal quadratic equation question. Like it's just solve the quadratic equation, except that some of the coefficients, some of our A, B, C values, they are complex. So yeah, let's just copy down the equation. Okay, now we're going to note our A value. So A is the coefficient of W squared. So A is just 2 plus I. And then B is the coefficient of W, so it's just 4. And then C is just the constant term, which is 2 minus I. Yeah, so we're going to now use our quadratic formula. So minus B, that's just minus 4 plus or minus square root of B squared, which is 4 squared minus 4 times A, which is 2 plus I times C, 2 minus I over 2A. So 2 times 2 plus I. Okay, so we get minus 4 plus or minus square root of 4 squared, which is 16, minus 4 times. So 2 plus I times 2 minus I. It is in this form of A plus B times A minus B. You will get A squared minus B squared. So here it's just going to be 2 squared minus I squared. And we know I squared is just -1. So 2 squared minus -1. So 4 minus -1. You get 4 plus 1, which is 5. And then over 2 times 2, that's 4, plus 2 times I, which is 2 over I. Okay, and then you just simplify everything inside the square root. You would get 16 minus 20. You get minus 20 plus 16, which is minus 4 over 4 plus 2I. And then you get minus 4 plus or minus square root 4 times square root -1. And square root 4 is just 2. Square root -1 is I over 4 plus 2I. Okay. Yeah, let's split the positive negative signs. So for positive sign, we get minus 4 plus 2I over 4 plus 2I. And for the for negative sign, we get minus 4 minus 2I over 4 plus 2I. Okay, so let's deal with this first. So to deal with this, you have to first rationalize the denominator. So what we mean is we are going to make the denominator real. So to make this real, we have to multiply it by the conjugate. So this 4 plus 2I, the conjugate would just be 4 minus 2I. And you also multiply by the same conjugate with the numerator. So minus 4. So minus 4 times 4 minus 2I plus 2I times 4 minus 2I. And then for the denominator, it's in this form. So A squared minus B squared, you get 4 squared, which is 16 minus 2I squared. So 2I squared, you get 2 squared, which is 4, then I squared. I squared is -1, so minus 4. So you would get minus 4. You would get 4 squared minus 2I squared, minus 4, so plus 4. Okay, yeah. Then just expand out everything, you get minus 16 plus minus 4 times minus 2i, you get plus 8i. And then 2i times 4, you get plus 8i. 2i times negative 2i, you get minus 4i squared. So minus 4i squared, that would just be 4. That should just be 4, right? Yeah. And then over 20 and minus 16 plus 4, that's minus 12. 8i plus 8i, that's 16i over 20. So just split up the fraction. So minus 20 divided by 20, you get minus 3 over 5. And 16i divided by 20, you get plus 4 over 5i. So yeah, this is one of the answers. And as for this, if you realize the numerator, you can factor out the negative 1. So you get negative 4 plus 2i over 4 plus 2i. And then you can just cancel out. Your final answer would just be negative 1. So yeah, this would be the final answer. Let's see if it, okay. Just to be safe, please write it as negative 1 plus 0i. Or you can just write negative 1, but I like to be like extra cautious, so I even included the 0i. So yeah, these would be our two final answers. If you want to check whether both of these are correct, just go into the complex mode of your calculator and substitute these exact complex numbers back into this equation, back into the left-hand side, and see whether you get 0. So yeah, this would be our final answer for this question. Let's head on to next question. Okay, so for this question, we're told that the parametric equations of a curve are x equals to this and y equals to this. So both of them are expressed in terms of t. So we need to obtain a simplified expression for dy dx in terms of t. Okay, so to do this, we first need to know the formula. So to get dy dx in terms of t, we need to use the chain rule. So to form the formula, we first fill the numerators dy for the first one and then multiply by the second fraction where the denominator would be dx. And then the blank spaces, these would be the same expression. So in this case, we can only have dt. So dy dt times dt dx. And multiplying by dt dx is also the same as dividing by dx dt. So in short, dy dx is equals to dy dt divided by dx dt. So let's evaluate dy dt and dx dt. So let's do dy dt first. So y is equals to t over 2t plus 1. So to get dy dt for this, you can see it's a fraction where both the numerator and denominator are functions of t. So for a case like this, we are going to have to use the quotient rule. So yeah, let's do that. So how I like to do it is to first square the denominator. So 2t plus 1 squared. And then you bring the denominator up, you multiply it, keep it, and then you multiply this by the derivative of the numerator. So derivative of numerator is just 1. So you multiply by 1, then minus, you keep the numerator, so t, and then you multiply by the derivative of the numerator, of the denominator. So denominator is 2t plus 1. You multiply, you differentiate, you will get 2. So you just multiply by 2. So simplifying this, you'll get 2t plus 1 minus 2t over 2t plus 1 squared. Yeah, so 2t minus 2t gets cancelled out. You would get 1 over 2t plus 1 squared as your final answer. Okay, now let's differentiate dx. Now let's find out dx dt. So x is just t squared minus ln 2t plus 1. So this one's a lot simpler. It's just the sum of it. So you differentiate your 2t first, you get as t squared, you get 2t, and you minus the derivative of ln 2t plus 1. So differentiate it, you put 2t plus 1 in the denominator, okay? You put whatever's inside the ln in the denominator, and then in the numerator, you differentiate whatever's inside, so in this case 2t plus 1, and then you put the derivative as the numerator. So the numerator would be 2. And since we're going to divide dx dt, it's best that we express this as a single fraction first. So let's make both of the numerators the same. So 2t times 2t plus 1 minus 2 over 2t plus 1. Yeah, you would get 2 times 2, 2t times 2t, you get 4t squared. 2t times 1 you get plus 2t over 2t plus 1 minus 2 over 2t plus 1 equals 2t plus 1 over 4t squared plus 2t minus 2. Okay, and then we can see that for the numerator, it's a quadratic, so we can try factorizing it. So first, let's factorize the 2's. Since all the coefficients are multiples of 2, they're all even. So we get 2 times 2t squared plus t minus 1 over 2t plus 1. And now we can factorize the quadratic expression. You would get 2 times 2t minus 1 times t plus 1 over 2t plus 1. Yeah, so this is dx dt. Now we're ready to find dy dx. So you will take your dy dt first. So 1 over 2t plus 1 squared divided by dx dt. So divide by 2 times 2t, 2, sorry, minus 2t minus 1 times t plus 1 over 2t plus 1. And you do your keep change flip. So you change the division sign to times, so you'll get 2t plus 1 over 2 times 2t minus 1 times t plus 1. So you can cancel this out. Yeah, and then you can multiply, and you'll get your final answers 1 over 2 times 2t plus 1 times 2t minus 1 times t plus 1. So yeah, this would be a final answer for this entire question. Let's head on to the next question. Okay, so we are given a differential equation in terms of x and y. So this is a differential equation where k is a constant, and our initial conditions are y equals to 0 when x equals to 0. Oh, and then we're given another set that y equals to half when x equals to 1. So I'm just going to box those. So we have 2 of them. And we're told to solve the differential equation and find the exact value of y when x equals to square root 3. Okay, so let's copy down the differential equation first. And by now, we are supposed to know that when we are solving a differential equation, we are supposed to separate the variables. So we do that by multiplying both sides by dx first. And now we are going to bring all the x variables to the left-hand side where dx is, and all the y variables to the left side where dy is. So we're going to divide both sides by e to the power of 2y. Then you get e to the power of 2y. And then you also divide both sides by x squared plus 1. Then we would get kx divided by x squared plus 1 dx. So we can integrate these two. So this one we can re-express it as e to the power of negative 2y dy equals to the integral of kx over x squared plus 1 dx. Okay, so to integrate the left-hand side, very simple. Just take the derivative of the power. So that's just -2, and you divide it by the original exponential. So this would just be -12 times negative 2y plus c. You can keep the plus c on on either side. And to differentiate this, we should first take a look at the degrees of the numerator and the denominator. So the degree of the denominator is 2, since the highest degree is 2, and that of the numerator is 1, since, the highest power is 1. And we can say that the degree of the numerator is 1 less than that of the denominator. And whenever that is the case, we know that this is going to be a ln expression. So we have to differentiate the denominator. So differentiating it, you would get 2x. So we can put 2x over x squared plus 1. And then to preserve the k, wait a minute. Okay, let's just okay, so to keep the k, we're gonna keep the k, and we will put 1 over k outside of the integral sign so that the expression doesn't change. Wait, no, actually we're supposed to put 1 over 2, not 1 over k, since that would change the expression. So by putting 1 over 2 and 2, the expression still remains as kx over x squared plus 1. So that's what you do. You differentiate the denominator, and then you put the coefficient of the derivative of the you put the coefficient of the term of the highest degree of the denominator into the expression, and then you divide it by the same number outside of the integral sign. Okay, so enough of all that. Now we are ready to integrate. So, okay, first we should remove the k as well. So now we have k over 2 outside of the integral. So now we just have to integrate 2x over x squared plus 1. So that is very simple. It's in the form f prime x over fx. So it's just ln of x squared plus 1. Yeah, so now, oh, sorry, I forgot to put the k over 2. Yeah, so k over 2 ln x squared plus 1. So now we're going to substitute our initial conditions. So we will sub x equals to 0 and y equals to 0. Okay, so substituting y equals to 0 on the left-hand side, we get minus half times e to the power of 0, which is 1, then plus c equals to k over 2 ln x squared is 0 squared. So 0 plus 1, you get k over 2 ln 1. So ln 1 is just 0. So you get minus half plus c equals to 0. And then c would just be half. So substituting back into our original equation, we can say half minus half times e to the power of negative 2y is equals to k over 2 ln x squared plus 1. Okay, it's 2 pages. Yeah, so now the only unknown we have to solve is k, and for that we are going to use the second set of initial conditions. So we'll sub y equals to minus half and x equals to 1. So we get half minus half times e to the power of negative 2 times negative half equals to k over 2 ln 1 squared plus 1, you get just ln 2. And then half e to the power of negative 2 times negative half, you just get e. So half minus half e, you get k ln 2. So multiply both sides by 2, you get 1 minus e equals to k ln 2. And to get k, just divide both sides by ln 2. You get 1 minus e over ln 2. So yeah, we're just gonna keep this exactly as it is. We're not going to approximate it. So yeah, so our final differential equation will be half minus half e to the power of negative 2y equals to k over 2. So 1 minus e over 2 ln 2 ln x squared plus 1. Okay, so yeah, this would be our final equation. Now we will just substitute x equals to 3, x equals to square root 3, sorry, and find the value of y, which is the second requirement of the question. Yeah, so this is the first answer. Now we're going to find our second answer. So half minus half e to the power of negative 2y, 1 minus e, 2 ln 2. We can use the product rule, make this the power. So you just get ln 2 squared. So that's just ln 4 times ln x squared. So x squared is 3. 3 plus 1, that's just 4. So you get ln 4 over ln 4. So these two cancel out. And you would get half minus half times e to the power of negative 2y equals to 1 minus e. And now we're going to isolate the term that has e. So this would just become half times e to the power of negative 2y equals to half minus bracket 1 minus e. And now we multiply both sides by 2. You get e to the power of negative 2y as 1 minus 2 plus 2e. So I open up the brackets and multiply it by 2 at the same time. So you get e to the power of negative 2y as 2e minus 1. And just take ln on both sides. Okay, so ln e to the power of negative 2y, ln times 2e minus 1. Then you can use the product rule, bring down this power, and make it as a coefficient, and you get minus 2y ln e equals to ln times ln 2e minus 1. So, and ln e, that's just 1. So you will get y equals to negative half. I'm dividing by negative 2, then you get y equals to negative half ln modulus of 2e minus 1. So yeah, this would be our final answer, our second answer for this question. If you want to check whether if you want to be sure of your answer, you can substitute this directly into the equation. Actually, never mind. Just just see whether you made any arithmetic errors or any sign errors. So yeah, with that, let's head on to the next question. Okay, so for this question, we are told by sketching a suitable pair of graphs, we have to show that this equation has only one root in the interval x is between 0 and pi over 2. So to figure out what graphs you have to draw, just look at both sides of the equation. We can see that the two graphs are y equals to secant 2x and y equals to negative e to the power of x. So let's draw them both in this interval. So this is 0, pi over 2, and the midpoint would be pi over 4. Okay, so to draw the first one, y equals to secant 2x, we're just gonna substitute like values. Okay, so let's substitute 0 first. So secant 2 times 0, so 1 over cosine 2 times 0, you would get 1. So I'm just going to put 1 here. And if you substitute secant 2 times pi over 4, you will get math error. So that means that this here is an asymptote. And now let's do for pi over 2. You would get negative 1. So negative 1 somewhere here. Okay, so let's substitute values of x between 0 and pi over 4 first to see whether it's increasing or decreasing. So one value we can do is pi over 6, that's between 0 and pi over 4. So for pi over 6, which is like here, I got 2. So yeah, that's 1 point. So we can see that clearly it is increasing. Yeah, so I'm just going to stop there for the range between 0 and pi over 4. And as for between pi over 4 and pi over 2, we are going to substitute to see whether it's increasing or decreasing. We're going to substitute pi over 3. So for that, I got negative 2, which is somewhere here, and pi over 2 is here. So, and this is here, so yeah. Okay. I think that's a bit, yeah, I think I'm just gonna yeah, okay. I think this is perfect. Yeah, so this is gonna be y equals to secant 2x y equals to secant 2x. And now we're going to sketch y equals to negative e to the power of x. So similarly for y equals to secant x, we're also going to substitute values of x into y equals to negative e to the power of x. So I'm substituting x equals to 0 because I don't like memorize the shapes of the graphs. So we got -1 for negative e to the power of x. Now we're going to substitute pi over 4, which is, yeah, you get -2.2, which is definitely like here. Yeah, and then if you substitute like bigger values, you get bigger negative values. So it will just go downwards. So I'm just gonna draw, should be something like this. I know it's a bit out of range, but that's the best I can do. Yeah, so this is y equals to negative e to the power of x. And as we can see, there is one point of intersection, which is right here. And so we can say, since there is one point of intersection, uh, the equation has one root. We can just stop here. And yeah, this would be our final answer for this first part. Let's head on to the second part. Okay, so we are told to show by calculation that this root lies between 0.9 and 1. Okay, so to do this type of question, what I like to do first is to take the equation. So I'm gonna take the equation above and make one side equals to 0. So we can just add e to the power of x to both sides. Then we'll get secant 2x plus e to the power of x equals to 0. And now we can substitute both of these values. So let's start with x equals to 0.9. So x equals to 0.9, you get secant times 2 times secant 2 times 0.9 plus e to the power of 0.9. You will get, so secant is just 1 over cosine. So 1 over cosine times 2 times 0.9. And make sure your calculator is in radian mode. Okay, so we get a negative value. I'm just going to express 3 as stuff. So -194. So this is 0, less than 0. Now we're going to substitute x equals to 1. So what I'm expecting here is we'll get a positive value, and then we can say since it's a sign change, the root definitely lies between 0.9 and 1. But let's not jinx ourselves. Okay. Oh, sorry. Okay, so I got 0.315 to 3SF, which is more than 0. So yeah, now we can say that since there is a sign change, this root lies between 0.9 and 1. Yeah, so this would be our final answer for the second part. Oh, don't forget to write shown. Let's head on to the next part. Okay, so now we are told that show if a sequence of values given by this iterative formula converges, then it converges to the root of the equation in part A. So yeah, at first glance, you can see that the wording is very complicated, but what they want you to do is to take the iterative formula and show that it reduces back to this equation that they give us initially. So let's just copy down the iterative formula, excluding all the n's. So you just get x equals to half cosine inverse minus e to the power of negative x. Okay, so, okay, no problem. Yeah, so to do this, yeah, just multiply by 2 first. So 2x equals to cosine inverse negative e to the power of x. And now remove the cosine inverse, and you would just get cosine 2x equals to minus e to the power of negative x. And now we can rewrite negative e to the power of negative x as negative 1 over e to the power of x. And now we have to make e to the power of x the subject of the equation. So by doing that, you would get e to the power of x is equals to minus 1 over cosine 2x. So 1 over cosine 2x, that's just minus secant 2x equals to e to the power of 2x. And yeah, you would get secant 2x equals to minus e to the power of x. Yeah, so as you can see, that's exactly the equation in part A. So we can write shown here. And yeah, this would be a final answer for this part C. Let's head on to the last part. Okay, so now here comes the fun bit. We are going to use this iterative formula to calculate x to 3 decimal places, and each iteration should be given to 5 decimal places. Okay, so to start off, our initial x value has to be between 0.9 and 1. So I'm just going to choose the middle value, which is 0.95. And to do this type of question, you substitute your initial value into this part of the formula. So half cosine inverse minus e to the power of negative x, so negative 0.95. I actually set 0.95 as the answer, and then you substitute the answer into this part of the iterative formula, the more complicated part. And then you'll get, and when you press equals, you would get your first iteration. So for me, I got 0.98395. Yeah, that's to 5 decimal places. Okay, and then you press the equal signs again to get your next iteration, and so on and so forth. So for this, I got 0.97697. So you should stop when you realize that your values are very close enough, and when you round them off to 3 decimal places, your last 2 iterations, they give you the same answer. Obviously, you can stop like me when both of the answers are exactly the same. So I'm just going to continue. So x4, you get 0.97838. Yeah, it's starting to hover around 0.97, but it's not the same. So I'm just gonna keep continuing. Okay, we got 0.978097809, and x6. We got 0.97815, and x7. We'll get 0.97816. 0.814. So you can see they're starting to hover on very close to each other. Okay, and then x8 will get 0.97814. So now the last two iterations are exactly the same. So we can conclude our answer as x equals to 0.978 to 3 decimal places. So this would be our final answer for this part as well as the entire question. Let's head on to the next question. Okay, so for this question, we are told that fx is this expression. So for the first part, we need to express fx in partial fractions. Before we do the whole general like process of expressing this in partial fractions, we should take note of the degree of both the numerator and the denominator. So the degree of the numerator is 3. And if you realize the degree of the denominator, if you expand it out, is also 3. So when the degree of the numerator is more than or equal to the degree of the denominator, you have to do long division first. And then after that, you can do partial fractions. You'll see what I mean when I do this question. So let's do it. So let's expand the denominator first. So 3 plus x times 2 plus x squared. So you get x times x squared is x cubed. Then you get plus 3x squared. Oh, sorry. And then you get plus 2x plus 6. So 3 times 2, you get 6. Okay, let's see if that's all. Yeah, okay, yeah, that's all. Now we're ready to do long division. So we'll divide this by this. So remember x cubed. So there's no x squared term. We'll just write 0x squared plus 2x minus 11 divided by x cubed plus 3x squared plus 2x plus 6. Okay, now we are going to make the coefficient of x cubed the same as this. I mean, it's already the same, so we can just go ahead and subtract. And don't forget to put the number that we had to multiply this before we subtracted. So in this case, since we didn't multiply anything, we can just put 1 as our quotient. And now we can subtract. So x cubed minus x cubed is 0. 0 minus 0, x squared minus 3x squared, that's minus 3x squared. 2x minus 2x, that's 0. And minus 11 minus 6, that is minus 17. So minus 3x squared minus 17, that's the remainder. So to re-express fx, you put the quotient first, so 1, and then plus, put the remainder as the numerator, so minus 3x squared minus 17 over the denominator as we previously got, not the expanded form. So 3 plus x plus 2 plus x squared. So I would like to remove the negative sign. So you'll get 1 minus 3x squared plus 17 over x plus 3 times x squared plus 2. Yeah, so this is our fx. So now we are ready to express this in terms of partial fractions. Okay, so let's start. So 3x squared plus 17 over x plus 3 times x squared plus 2 we can express as a over x plus 3. And for the term where the denominator is x squared plus 2, since this quadratic expression, we cannot factorize it, the denominator would be in the form, the numerator would be it would be in the form bx plus c. So yeah, now we're gonna multiply both sides by the denominator of the second of the left hand side. So you would get 3x squared plus 17 equals to a times. So you multiply x plus 3 with this, the x plus 3 goes away. So we have a times x squared plus 2. And then for bx plus c, since the denominator is x squared plus 2, you multiply x squared plus 2. It goes away. So you only have bx plus c times x plus 3. Okay, so now we are supposed to look for a vector which we can equate to 0. So in this case, it would be this one. We can equate to 0 when x is equals to -3. So that should be your first instinct, to look for any factors that you can equate to 0 and then finding the value of x for which you can do so. So in this case, we can do for this by substituting x equals to -3. So this becomes 0. This also becomes 0. So we just have to find this. So -3 squared, that is 9. So 9 plus 2, that's 11. So you get 11a equals to 3x squared. So 3 times -3 squared. -3 squared, -3 squared, you get 9. So 3 times 9 is 27. 27 plus 17 should be 44. Okay, perfect number. And then you would get a is equals to 4. Okay, so after we substitute this, since we cannot factor out, since there's no other factors for which we can equate to 0, our next solution is to substitute x equals to 0. So that's what you're supposed to do. Either substitute x equals to 0 or x equals to 1. Or if you have already done both of those, substitute x equals to -1. So yeah, keep the numbers as simple as possible. So for a, okay, let's substitute here. So b times 0, that's 0. So 0 plus c, you just get c. C times 0 plus 3, you get 3. So 3c. And then plus a, which is 4, times 0 squared, which is 0 plus 2, which is 2. And you equate it to 3 times 0 squared is 0, and then 17. Then you get 3c equals to 9, and c equals to 3. Yeah? Okay, so we have not found all of them. We are still remaining, we still haven't found b. So to find that, we're going to substitute x equals to 1. Okay, so b times 1, so b plus c. So b plus c, so b plus 3 times 1 plus 3. That is 4 plus a. So plus 4 times 1 squared. So 1 plus 2, that's 3, equals to 3 times 1 squared. That's 3 times 1. So 3 plus 17, you get 20. Okay, then you get 4 b plus 3. So 4 times 3 is 12. 20 minus 12, you get 8. B plus 3. 8 divided by 4, you get 2. And then B, you get minus 1. Let me just substitute back. So minus 1 plus 3, you get 2. So 4 times 2, you get 8. 8 plus 12, yeah, 20. So yeah, B is negative 1, and we have found all of our unknown constants. So yeah, now we express 3x squared plus 17 over x plus 3 times x squared plus 2 as a, which is 4 over x plus 3, plus bx, which is minus x, plus c, so plus 3 over x squared plus 2. So this would just be, I'm just going to rearrange, just going to swap it. So 4 over 3 plus x plus 2 plus x squared over 3 3 minus x. So yeah, this is it. So we can finally substitute. So we can finally express fx in partial fractions as 1 minus for 3 plus x plus 3 minus x over 2 plus x squared equals to 1 minus 4 over 3 plus x minus 3 minus x over 2 plus x squared. And since I don't like the negative sign here, I'm just going to factorize it out, but this one's up to you. So 1 minus 4 over 3 plus x plus x minus 3 over 2 plus x squared. Yeah, so this would be our final answer for the first part. Let's head on to the second part. Okay, so for part B, we're told to obtain the expansion of fx in ascending powers of x up to and including the term in x squared. So basically, we are supposed to expand this and arrange the terms from the constant term, then the term in x, and then finally the term in x squared. So to get the expansion, let's first get fx. And yeah, let's write down fx first. And all the denominators, we can re-express them by converting the power to a negative power. So 1 minus 4 times 3 plus x to the power of negative 1 plus x minus 3 times 2 plus x squared to the power of negative 1. Okay, so let's take a look at the binomial expansion formula for rational powers. So the formula that they give us here, one condition is that the constant term has to be 1. So if we don't make it 1, this formula would not apply. Yeah, so just take a look at the formula. So since we're expanding up to the term in x squared, we just need up to here. So 1 plus nx plus n times n minus 1 over 2 factorial x squared. So let's do that. So 1 minus 4. To make this 1, we can factor out 3 So 3 times 1 plus x over 3 to the whole thing to the power of -1 plus x minus 3 times factor out 2 here, so 2 times 1 plus x squared over 2, whole thing to the power of -1. Okay, so you get 1 minus 4, spread both of the powers to both of the terms, so you get 3 to the power of -1 times 1 plus x over 3 to the power of -1 plus x minus 3 times, also spread the powers over to each other. So 2 to the power of -1, you get half times 1 plus x squared over 2 to the power of -1. So expanding all this, you would get 1 minus 4 over 3 times 1 plus x over 3 to the power of -1 plus x minus 3. So just bring the half over here, times 1 plus x squared over 2 to the power of -1. So now we can start expanding the expressions which have rational powers. So 1 plus x, so you start with 1 plus nx, so n is the power, so minus 1 times x, so x is this, so x over 3 plus n times n minus 1, so minus 1, you get minus 2 over 2 factorial times x squared, which is x over 3 squared, then dot dot dot. And then plus half times x minus 3. For this one, yeah, the same thing. So 1 minus plus nx, so minus 1 times x, so x squared. And for this, we can stop right here, because if we continue up to the next term, we would get the term in x to the power 4, which we're not interested in. So to save our time and effort, we can just stop here. Okay? Okay, now let's simplify everything. So 1 minus 4 over 3 times 1 minus x over 3 minus 1 times minus 2, that's 2 over 2 factorial, that's 1, then plus x squared over 9 plus half times x minus 3 times 1 minus x squared over 2 goes to 1 minus, just expand this out, minus 4 over 3 times 1, so minus 4 over 3, minus 4 over 3 times minus x over 3, so plus 4 over 9x minus 4 over 3 times 1 x squared over 9, so minus 4 over 27 x squared. And then plus half times, so to expand this, we're going to use the rainbow method. So x times 1 minus x squared over 2. So x times 1, you get x. And then minus x times x squared over 2, you get x cubed over 2. And then minus 3 times 1, you get minus 3. Minus 3 times negative x over 2, you get plus 3 over 2 x squared. Okay. Now, let's simplify. So minus 4 over 3 plus 1, you get negative 1/3 plus 4 over 9x minus 4 over 27x squared plus half bracket x, so half x The x cubed term we can ignore, and then half times -3, you get -3/2, and half times 3/2 x squared, you get plus 3/4 x squared. Okay, now let's just collect all the like terms together. So we have 1 minus 1/3. Wait, no, no, just minus 1/3, sorry. Minus 1/3 minus 3/2. You get minus 11/6. And for the x terms, you get 4/9x plus half x. You get plus 17/18x. And for the x squared terms, you get minus 4/27x squared plus 3/4x squared. You get plus 65/108x squared. So yeah, this would be our final answer for this question. And if you want to be kind of sure whether your expansion is correct, you can substitute a value of x into the original expression and substitute the same value of x into here. If you get the same answer, then you know your partial fraction decomposition is correct. And if you want to know whether your expansion is correct, substitute the same number into your expansion and see if your values are close. And if you're not convinced, you can try it with other values of x as well. Yeah, so that's the best way to check, in my opinion. And with that, let's head on to the last question. Okay, so for this question, we are told with respect to origin O, the points A, B, and C, A, B, C, D have the position vectors given by this. So these four vectors are the position vectors of A, B, C, and D. And we're also told that the line M passes through the points A and B. And for the first part, we are told to find a vector equation for M. Okay, so to find the vector equation for any line, the format is such that you put the position vector of a point along the line, okay, and then you add it with a scalar times the direction vector of the line. Yeah, so in this case, one position vector we can include is OA, and the direction vector, since it passes through points A and B, would be AB or BA. So in this case, I'm going to choose AB. So AB would just be OB minus OA. So that's 0, 4, 1 minus 1, 5, 3. You get minus 1, minus 1, minus 3 plus 1, that's minus 2. Okay, right. So M would be equal to OA. So OA is 1, 5, 3, or you can use OB as well. Any position vector along the line, plus the scalar, which is usually lambda, times the direction vector. So in this case, it can be 1, 1, 2, or -1, -1, -2. That's what I chose. And just to be safe, also express it in the IJK format. So in this case, it will be I plus 5J plus 3K plus lambda of 1I plus 1J plus 2K. Yeah, so this would be a final answer for the first part. Let's head on to the second part. Okay, so before starting part A, I just realized I made a minor mistake for part A, which is that I forgot to include R. So yeah, the R should be also included. Sorry for the minor mistake. Okay, let's head on to part B. So for part B, we need to find the position vector of the point of intersection of M and the line passing through the points C and D. Okay, so first of all, to find any point of intersection between two lines expressed as vectors, we need to know both of the lines' vector equations. So we know the vector equation of M, but we don't know the vector equation of the other line passing through the points C and D. So we're going to find that out. So same process. We know the position vector. I'm just going to choose C. We don't know the direction vector, so let's find it out. So I'm going to choose CD. So that's just OD minus OC. So OD is 3, -5, 4, minus OC, which is 1, -3, and 1. So 3 minus 1 is 2, -5 minus -3 is -2. 4 minus 1 is 3. Yeah, so this is CD. Okay, now, yeah, we can, in fact, we can form the equation. So just take the position vector of any point along the line. So I'm just going to take C. So 1, -3, 1 plus the scalar lambda times the direction vector, which is 2, -2, 3. Okay, so now let's take the equation for M. So 1, 5, 3 plus lambda 1, 1, 2. And let's fully expand them out. So for this, multiply lambda to each component. So you get 2 lambda minus 2 lambda and 3 lambda and add it up. So you get 2 lambda plus 1 and minus 2 lambda minus 3 and 3 lambda plus 1. And then for this one, you get lambda, lambda, 2 lambda. And you get lambda plus 1, lambda plus 5, and 2 lambda plus 3. Okay, yeah, the scalar cannot be the same for both of them. So I'm just going to put mu here. Sorry for the mistake. Yeah, so yeah, this is supposed to be 2 mu minus 2 mu, 2 mu. So this is mu. Sorry. Okay. Yeah, sorry for the mistake. Yeah, so let's equate these two. So we get 2 mu plus 1 equals to lambda plus 1. So we can minus 1 from both sides. We would get 2 mu equals to lambda. So this is equation 1. Now let's do the same for these two. So 2 mu minus 3 equals to lambda plus 5. You would get lambda equals to minus 2 mu minus 3 minus 5, which is minus 8. So that's equation 2. So equation 1, equation 2, both of them have lambda as a subject, so we can equate both of them. So 2 mu equals to minus 2 mu minus 8. So we can add 2 mu on both sides to get rid of this. So 2 mu plus 2 mu is 4 mu equals to -8. And then mu is minus 2. and then lambda would be 2 times mu. So 2 times -2 is -4. Okay, so you just have to find either one, so either mu or lambda. Yeah, so I'm just going to substitute into lambda to get our position vector. So -4 plus 1, that's -3. -4 plus 5, that's 1. 2 times 4, 2 that's -4, that's -8. Plus 3, that is -5. Yeah, so this is our position vector -3i plus j plus -5k. So yeah, this would be our final answer for this second part. Let's head on to the next part. Okay, so for this final part, we're supposed to find the position vector of the foot of the perpendicular from C to M. Okay, so to do this, first let's draw a sketch. So of line M and point C. So the foot of the perpendicular is basically the position vector of the line connecting from C to M, where these two lines are perpendicular. So this is the foot of the perpendicular. It's basically the intersection of the line perpendicular to M, joining with M at C, and the intersection point is the foot of the perpendicular. So we have to find this basically. Okay, so to do that, we're going to let this intersection point be F. Okay, so we're going to let F be a generic point on M. So OF would just be the generic point, which is this, which we found in the previous part. Yeah, so that's what the vector equation of a line represents, a generic point along the line. So it would just be lambda plus 1, lambda plus 5, and 2 lambda plus 3. Yeah, this from the vector equation of M. So yeah. Okay, and now we are going to find this line, CF. So CF would just be OF minus OC. So OF is lambda plus 1, lambda plus 5, 2 lambda plus 3 minus OC. OC is 1, -3, 1. So 1, -3, and 1. And then lambda plus 1 minus 1, you get lambda, and lambda plus 5 plus 3, minus -3 is the same as plus 3, then you get lambda plus 8, and 2 lambda plus 3 minus 1, you get 2 lambda plus 2. So this is CF. Now we're going to make use of our scalar product, which is given in our MF19. So the scalar product A dot B is just equals to the length of the two vectors cosine theta. So when theta is 90, cosine theta becomes 0. Hence, A dot B will also be 0. So we can say that the scalar product of the direction vector of M, which we found out to be 1, 1, 2, dotted with CF lambda, lambda plus 8, and 2 lambda plus 2, we can make it equals to 0. So 1 times lambda is lambda plus 1 times lambda plus 8, lambda plus 8, and then 2 times 2 lambda plus 2, you get 4 lambda plus 4 equals to 0. So lambda plus 4 lambda, you will get 6 lambda equals to 8 plus 4, that's 12. So move it to the other side, you get negative 12. And lambda, you would get minus 2. Okay, and then to find the foot of the perpendicular, which is OF, just substitute it back. You would get minus 2 plus 1, minus 2 plus 5, 2 times minus 2 plus 3. So minus 2 plus 1, it's minus 1. And minus 2 plus 5 is 3. And minus 2 times negative 2, that's minus 4 plus 3, you get minus 1. So this would be our final answer for the foot of the perpendicular, minus 1 times 3 times negative 1. And we have come to the end of this question as well as the entire paper. So I hope you guys enjoyed this video. If you did, please make sure to like and subscribe to this video and to this channel for future videos like this. If you have any feedback for me, any questions or any suggestions on the type of content I should do, feel free to leave them down in the comments below, and I will see you guys again next time. Okay, thank you.